when we substitute this back into here, we see that VNP is just V in, it's whatever signal we're giving in there. And then the A here, because of how large it is with just the op amp, it'll get canceled out within these equations to be where the gain after feedback is only dependent on the values of the resistors you use. And you can change these around, so it doesn't have to just be 10K and 100K. We can keep 10K here and then substitute this for a 33K resistor. And so instead of 10X, you'll get 3X. This is everything built onto the breadboard. We have pretty much the same setup here with the batteries that creates the +9 and -9 volts. And then the signal we're giving into it is a 0.3 volts sine wave. And then same thing here, the frequency could change. And then out onto the oscilloscope, you're seeing the input wave, which is yellow here, and then the output wave after amplification, which is the blue wave. And then with this, you're not having any inverting. So whenever the yellow wave reaches its peak, the blue wave will also reach its peak. And because of the formula and the different resistors we use here, we're getting an 11x gain because it's 1 plus RF divided by R1, and we're using 100K and 10K. So now what we can do is change the volts per division on the oscilloscope for the input wave. So if we change it, now the input and output waves have different volts per division, but we see that the waves pretty much match up one on top of another here. Now what we'll do is we'll change the feedback resistor to a 33K resistor instead of 100K. And what you'll see is the output wave will fall because instead of a 10x gain, it'll be just a 3.3x gain. So you can change the resistor value here. And then now we have that output waveform fell. It's still amplifying, just because of how we set up the oscilloscope with the volts per division. It doesn't look like it, but it's still larger than the input waveform. But it's now just a 3.3x gain instead of nearly a 10x gain. We can make the volts per division the same again, and now you can see that it's less drastic than it was before.